Yes, put it in your binder. Okay, 7.7. Yeah, please put your college entrance test prep 6 and 7 in your folder. There really shouldn't be anything else in there except some graded quizzes and tests. Other than that, empty. Okay, 7.7. We're going to be talking about more radical equations. You guys ready? Yes? Ready or not? Here we go. You know it's true. I see you all doing it. Right? True? Okay. All right. So now we're going to have variables under more than one radical. And we've got to figure out how to solve. So what we want to do is isolate the radical that's more complicated. And then what do we do when we have that radical all by itself on one side of the equal sign? Well, if it's a square root, we raise it to the second power. Cube root, we cube it, right? We raise it to the index of the radical. So yes, I'm probably not going to do a ton of cube roots in the homework. I'm going to mostly do squares. So here's an example. I cannot combine these. Guys, be careful. I see you guys doing stuff that just isn't good math. You just can't. These are not like radicals, so we can't add and subtract them. Remember that rule? Okay, so what I want to do, which one is more complicated? I'm sorry? The first one, x plus 33, is more complicated. Okay, so I'm going to isolate that one. So what do I need to do to get it all by itself? Isolate means get it by itself. Add square root of x to both sides. Okay, so now we said once we isolate it, we're going to raise it to the power to get rid of the radical. So it's a square root, so I'm going to square both sides. Now, here's what I want you to be careful about. This is a binomial. You are squaring, which means you're foiling. You are foiling this. This is 3 plus square root x times 3 plus square root x. So someone FOIL that before I show the answer of what they get. This one's easy, right? The x plus 33, the square root of it squared, just makes the radical go away. So we'll just have x plus 33. But over here, we're going to have a little bit more complicated thing happening. Someone have it or have a guess? Eli, you got a guess for me? Not yet. Josiah, you got a guess for me? I'm sorry? Yeah, it's going to end up being a trinomial, right? So my first term is going to be 9. What's my middle term? 6 times. It'll be 6 square root x, right? And then what's my last term? Love that. Good job, Caleb. That's exactly right. Anybody not get that or doesn't know how I got it? Do you need me to do the foiling? Because when I do my inside terms, like this would be a 3 over here, I would have had 3 times square root x. Then my last terms would be 3 square root x. So together I'll have 6 of them. Does that make sense? I have 2, 3 square root x's that I add together, because those are like radicals. Okay, so now aren't I down to just one radical now? So I just have this extra step. When I have a radical, what do I have to do? But I can't combine. I'm going to isolate it, right? Because don't I want to square something again to get that x out of there? It's the only way to get the x out of the little house is to get it by itself so I can square everything. So now I've got to move everything away from it again. So you see how I'm going to have to do it twice. I have two radicals I can't combine. That means I'm going to have to isolate twice. So I went ahead and subtracted x from both sides. They went away. Then I subtracted 33 from both sides. That gives me the negative 24. And I went ahead and subtracted this whole thing over. Now, I would go ahead and divide by negative 6 on both sides before I squared, but I think your book goes ahead and squares. Oh, no. Okay, good. They do that in one of the examples. They don't get it isolated enough for me, but okay, so if I divide by negative 6, I get positive 4, and now I'm squaring. So what happens when I square? X, good. Now, what if, well, maybe this. Does it work? Does it work? What's the answer? 3, okay. Yes? All right, so this one, we still have two variables, but only one radical. What do you think? Any ideas of what we should do first? Well, yes. And then what happens when right now, I don't want to divide. This is where I don't divide by 3, because when I have a crazy fraction, there's not anything it'll just make it harder when I square, when I have a fraction squared. And you don't really like fractions very much, so let's just leave it like this and then square. Is that okay? So someone tell me what this trinomial will be when you square it. Mel wants to do it. Go ahead and foil over there. I could just read your face over there. Tell me what you get, Mel. Let me know when you're ready. No, just 10 minus x squared. Not 10x. You forgot one part. You got most of it. You did 3 of the 4 letters. If here I have a 10, that gives me the negative 10. But what about this and the last? That's another negative 10x, isn't it? Okay. I'll have 2 of them. Your inside and your outside for FOIL. You got the first and last just right. But the outside and inside. That make sense? Okay. All right, and so when I square this, remember you have to square all the parts, right? So my x comes out, and my 3 squared is 9. So now I still have this weirdness, but I'm going to go ahead and put that 9x over and set it all equal to 0, and then I have a quadratic that I need to solve. We should be experts in solving quadratics as much time as we have spent here. This is chapter 6 from. Factor if you can. Can I factor this? Let me just say yes, it factors. It factors. Who wants to tell me what it factors? What are some factors of 100 besides 10 and 10? I'm sorry? 25 and 4. Like quarters equal $1. Okay? And they add up to 29, right? So now I'm going to set both factors equal to 0. Yes? Familiar territory, I hope. Okay. So I get x is 25 and x is 4. Now what do I have to do? Check. Check them both and tell me if they both work. Somebody, how about Maya, you check 25, and Daniel, you check 4. Tell me if they work. Maya, you said 25 does not work. I agree. 4, does it work? It does. Okay, so the only solution is 4. Your answer is 4 at the end of it all. The check step, again, is super important because you have a radical in there. Whenever you have a radical, you've got to check. I mean, you got to check anyway, but radical makes it extra important. Questions on this? Questions on this? Isolate the radical, right? Same first step in all of these. Isolate the radical. Square, and this time we ended up with an x squared, so we had to go back to the old stuff. Okay, so now what happens when we have x to a fraction? This is a rational exponent, which remember, if I have a fraction as an exponent, it's the same as having a radical, just a different form of a radical. Remember, the denominator is the index of the radical. Do you remember this? Section, what, 3, I think? Something like that, somewhere in there. So fractions are the same as having radicals. The denominator is the index. So you can rewrite it and then try to solve it that way, but there's a shortcut where if I multiply by the reciprocal, what will my exponent be? 1. And isn't that the same as getting rid of it? It's the same as squaring a square root or cubing a cube root. So we actually know a better way than translating it all back to radicals. Okay, this is actually a little bit easier, I think. Does anyone need more time on this side? Okay. Okay. All right, so here it is. First of all, what's the reciprocal of 2/5? 5/2, right? So I'm going to take that whole mess, and instead of having it squared and then to the 5th root, and instead of changing it to radical form, I'm just going to leave it like that. But I have to, what I do to one side, I have to do to the other. That's like the basis of, you guys did that in pre-algebra. When you add 3, you got to add 3 to both sides, right? So what happens on the left? Right, but, so what would my exponent be? That is true. What will my exponent be? 1. Okay, how about on the right? It's a number, hopefully. If it's not, how would I rewrite that in radical form? It is. It's the square root of 4 to the 5th. And since these are not matching, right, I'm going to have 1 in the house at least, right? 1 4 in the house, but isn't 4 a perfect square? So it all should just be a number at the end of it all. Okay. Remember your book is big on this absolute value thing. I am not. I'm totally, I would just, if I'm perfectly happy if you write 8 plus 7, then don't worry about the absolute values. Okay, is that all right? It just complicates things. Okay. So just like, who was it? Mel, was it you that told me? This is 4 to the 5th, square root of 4 to the 5th. Perfect. Okay, it actually is a number. So we have 8 plus 7 equals 32. Right? Your book is still doing the absolute value. Now, here's where it gets tricky. You have to know that anytime you square something, didn't we always say it's plus or minus the square root of whatever? Okay, that means we really are going to have 2 answers here. This part I don't care about. This part I do. So don't care about absolute value, do care about plus or minus 32. Because you're going to have two answers and you need to check them both. Because what if you only have one answer, you check it and it's wrong? You're going to say no solution, aren't you? Okay, so there is, but that might not be right. There might be a solution and you just didn't remember there's a minus there. Okay, so let's go ahead and solve both sides. Josiah, you check negative 39 and Jordan, check 25 for me. So plug those in for A in your calculator and tell me if you get 4. You got it? Okay, you check 39. So 39 you're saying is a negative 39 is solution. And 25 is also? Did anyone else check? Because somebody's not right, I just want to say. My bad, I thought one of these the next example. Too many examples. Sorry, you guys are right. Good job. Yay! Questions? Plus or minus thing? Questions on the plus or minus thing? No? Probably no. No one's going to ask me. Okay, so if a radical equation contains radicals with different indexes, so that means I've got a square root and a cube root. Or I've got a cube root and a 16th root. I mean, it doesn't matter. They're just different indexes. Then I need to raise both sides to the power that will make them both go away. So this is like a least common denominator scenario. Least common denominator. So if I've got a square and a cube, the thing that's going to make them both go away is raising it to the 6th power. Okay, so this is the least common, I would make a note, this is like the least common denominator so that you can make at least the smaller one be 1. When you have rational ones, it's easier to see, right? And when you have radicals, when you have fractions, isn't it easier to see? Oh, fractions mean least common denominator. Wait, let's practice. All right, so I got decimals, but don't I know what these decimals are as fractions? Yeah, what is 0.25? 1/4. What is 0.5? 1/2. All right. Oh, first of all, which one's smaller? 1/4. Isn't that also the least common denominator? Of a half and a quarter isn't a quarter, right? I can put them both in terms of fourth. Okay. All right, so if I raise them both to the 4th, won't the smaller go away? Okay, let's do it. What happens over here? What happens on the left-hand side? Good, because isn't 0.25 times 4 just 1? Okay, that's 4/4 equals $1 in case you're not sure. Okay, well now what if I have, I'm sure. Now what happens on the right? And is that okay? Do we know how to square that? How do we square that? FOIL. Good. So, who wants to FOIL it? Go ahead. You okay, Faye? You sure? Okay. Lost your smile. You usually lose it in this classroom. Maya, you foiling? Work on it, see if she's right, and she tells you. It's not going to be 1 on the end. Your first term's right. Oh. Keep trying. Caleb, what you got? Yes, it's strong.
3x, 2 6x.
Because you're going to have two of them. Your middle term is going to be, this is, let me just write it. I think I just tried to show you. Right? This gives me 6x and this gives me, right? It's my innies and my outies. Okay? And then this is, right? Are you with me now? Yeah, I couldn't figure out where you're getting a 1 from. I'm like, there's no 1 up there. Okay, so now, what do? I'm going to get everything on one side. So let's go and get everything on the right, set it equal to 0, and then what? Can I factor? Oh, it's a hard one to factor, but can it factor? Maybe? Well, it looks to me like it will, because like the 9 and 1 I can subtract off to get that 8. That's my guess, is that it can. I subtracted 4x from both sides. Now what do? Each one equal to 0. And then solve. Okay. Faith, will you check negative 120? And David, will you check 1/9 for me? Thank you. Tell me what you get. Tell me if it equals. When I put it in, now look, it's two-sided, right? So I don't know what number it's going to equal. You're going to have to check this, write down a number, check this, and see if it's the same number. Okay, a little bit more checking going on. Anyone else checking? You're all just waiting on your two friends to do it instead of doing it for yourself. I love that line. It's my favorite. Freya, did you check them both? So you think 1/9 works, and you don't think negative 1. I think you're both right. So when I put in negative 1, I get 1 does not equal I. Right? If I take the square root, it's going to be square root of negative 1 is not 1. Are you okay with my work there? Okay. I put in 1/9. It's kind of a mess, but it does work. Okay, but in your calculator, I know as long as you're telling me you're checking it, I'm good. You don't have to show me all this work on your check step. You do have to show me the work to get there in the first place.